Hey there, back again. This time we're going to look at the trigonometric functions sine, cosine, and tangent to help us out with solving for other parts of a right triangle. So just to review from our last video, remember that our right triangle is a right triangle because it has one 90-degree angle. And what we say is that that 90-degree angle, right, is always opposite with our hypotenuse. So it's always on the other side of our hypotenuse here. We're going to talk a little bit about what it means to be opposite and adjacent, because what the trigonometric functions do is they help us solve for the angles in our right triangle when they're unknowns. So right now we only know how to use the Pythagorean theorem, a squared plus b squared equals c squared. And that talks about the sides of our triangle. But what it doesn't do is talk about our angles. How do we find these things? How do we know what they are? Well, the trigonometric functions help us solve for those angles, or we can use those angles to help us solve for unknown sides if we know the measure of the angle. All right. So as we kind of move forward here, all right, these are the trigonometric functions, sine, cosine, and tangent. Right now, this would be a great time to pause the slides, all right, and write down each one of these functions so that we can talk about them in just a moment. But we're going to have to identify what opposite, adjacent, and hypotenuse are in our pictures. So pause now, write them down, and then we'll talk. All right. So if we're talking about opposite and adjacent when it comes to sides of a triangle, all right, opposite and adjacent have to do with how a side is related to an angle. All right? We're going to go ahead and we're going to label our triangle with our sides A, B, and C again. All right? So remember, this is side A, this is side B, and this is side C. What we're now going to do is we're going to label the angles of our triangle. And the way that they're labeled always has to be the same, so pay close attention. We don't switch angle A and angle B. So this angle right up here on the top of our triangle is going to be called angle B. And whenever we talk about angles, we use capital letters. And whenever we talk about sides, we use lowercase letters. And this angle right over here is going to be called angle A. So what we're going to notice is that every angle is made up of two sides, right? Angle B is made up of sides A and C. Angle A is made up of sides B and C. All right? And those are some of the things that we're going to use to help us understand what the words opposite and adjacent mean. All right, so I'm going to clear this real quickly. We'll start from scratch. So A, B, C, B, and A, just like that. Always in the same order there so that we don't get these things mixed up. All right, so let's talk about angle B first. All right, we already said that angle B is made up of two sides. It's made up of side A, and it's made up of side C. The first thing I want to talk about is side C. It's special in a right triangle. In a right triangle, side C is so special, it gets its own name. It is the hypotenuse. Hypotenuse. Sides A and B we know are legs, but they have a relationship with angle B. All right? So this is angle B right up here. And let's look at how sides A and B are related to it. Well, side A, right here, is one of the two sides that's helping create angle B, all right? So we notice that A and C, they come together at this point. They help make angle B. So if one of your sides is right next to your angle and helps make that angle, then we call that side adjacent. All right? So we would say side A is adjacent to angle B. It's adjacent to because adjacent means next to, all right? Or right nearby. Side C is the hypotenuse, and we never say that it's adjacent to an angle, even though technically it is, right? It helps make that angle. But C is special. C is the hypotenuse, all right? So we never call C adjacent, we just call it the hypotenuse, all right? Side B, hanging out here over on the opposite side of our triangle, we notice that this is the only side that doesn't help make our angle B. It's all the way over here, or opposite. On the opposite side of angle B. So we say that side B is opposite angle B. So we always see that opposite sides are on the opposite side of the actual triangle. So it kind of makes sense. Adjacent sides are right next to or help make the angle. And we can use that to kind of help us define opposite and adjacent. The reason we need these things is because sine, cosine, and tangent use the sides that are opposite, adjacent, and hypotenuse for specific angles. All right? So let's do the same thing for angle A. For angle A, we also have opposite and adjacent sides, right? Only this time, so angle A right here, that we have two sides again making our angle A that come together, right? In this case, side B is right next to angle A, right? Side B helps to make, with side C, the angle A itself. So we say side B is adjacent to angle A. It's adjacent because it's next to it, helps make it up. And since side A is all the way on the opposite side over here of the triangle, then we say that side A is opposite angle A. And that's actually the way that we give the angles their names. So we always name the angle based on the side that's opposite it. That's why I put A down here and B up here. That's all because we name them by their opposite sides. So now that we understand what opposite and adjacent are, we can use this to help us actually solve some problems with sine, cosine, and tangent. For our next video, we're actually going to do those examples for SOHCAHTOA. We're going to solve for sides and we're going to solve for angles. But if you want to use SOHCAHTOA, that is sine, cosine, and tangent, it's a quick way for us to remember, then these are your steps. We'll see you in the next video.